All right, so in 4-1, we covered these topics and we covered some of them in both radians and degrees. So like number 1 says find two coterminal angles, one positive and one negative, and this is in degrees, but make sure you also know how to do it in radians. So we talked about, that would have actually been the day before yesterday or on Friday. If we're doing coterminal and it's in degrees like the one that's on here, then we're gonna add and subtract from, no, not for coterminal. For coterminal, we're gonna do what? It's a whole circle, which would be what? 360. So I'm going to add, if my pen will cooperate. Nope. I'm going to add 360 to get a positive one. So 480 degrees would be my positive coterminal. And then I'm going to subtract 360. So I get 360 minus 120, 240, and it's negative. So negative 240 would be my negative coterminal angle. And remember, we talked about that sometimes you have to add more than once or sometimes you have to subtract more than once to make sure that when it's positive, it's positive. When it's negative, it's negative. If this was in radians, what would you be adding and subtracting? Good. Add and subtract 2 pi if radians, because that is one complete circle. So the circle, obviously in degrees, 360, but in radians, 2 pi. Then B is your complement and your supplement. Again, you want to know how to do this in both degrees and radians. Like this example is in radians, but we want to also know how to do it in degrees. If it was in degrees, then the complement would be 90 minus the angle, and the supplement 180 minus the angle. When it's in radians, like this one is, then I do pi over 2 minus the angle, and I do pi minus the angle. So for this one, I'm going to do pi over 2 minus pi over 3. I've got to change them so they both have a like denominator. So I'm going to multiply by 3 and 2 here. I get 3 pi over 6 minus 2 pi over 6, which is pi over 6. And that's your complement, A. And then for B, I subtract from pi. So pi minus pi over 3 would be 3 pi over 3 minus pi over 3, or 2 pi over 3. And that's B. Questions on those? Yep.
If it was negative,
We just say no. No complement, no supplement. So if it's bigger than a half or bigger than 90, no complement. If it's bigger than 180 or bigger than pi, no supplement. Yep, you don't want to give a negative answer for those. All right, then we did the conversion from radians to degrees and degrees to radians. How do I know if it's in radians or degrees? The degree symbol is your only guarantee, right? Because radians most of the time have pi, but they don't have to. So this is in degrees. I'm going to multiply it times pi over 180. The zeros cancel. 3 goes into both of these. This would be 5. This would be 6. So 5 pi over 6 would be your angle in radians. And then the number 4 on this slide is your arc length. This is your SOAR formula. Arc length equals theta times the radius. And what's true about theta? Has to be in radians. So I'm going to take my 210. I'm going to convert it to radians by multiplying by pi over 180. Cross through the zeros. 3 goes in both of these again. This would be 7, 6. So this is 7 pi over 6. And then I just take that and multiply it times the radius, which is 7, and I get 49 pi over 6. It's in inches because it's a length, so I keep it in terms of the inches. So lots of like little things you have to know from this section, right? How to convert from degrees to radians and then back again. Arc length, complement, supplement, coterminal angles. And then obviously today we're going to add on unit 2. Questions? All right. So unit 2 is called literally the unit circle. Yesterday we talked about how to fill it in. We'll talk about the pattern today. Tomorrow I'm going to give you a hard copy so you can practice it. Like I'll literally give you what you will see the next day on your quiz, and you will fill it in for practice, okay? But this is basically what we filled in yesterday, okay? We said we started with our quadrants. We did 0, pi over 2 at the top, pi on the left, 3 pi over 2 on the bottom, and then we would double back around to 2 pi. Actually, it would be under the 2 pi would be here. And degree-wise, it's 0 on the right, 90 at the top, 180 on the left, 270 on the bottom, and it would double back around to be 360 degrees on the right-hand side. And then we said the pattern for the degree was what? Good. 30, 15, 15, 30, all the way around your circle. So we filled in all of our degree measurements. Then we did our radians, and we said everything closest to the x-axis was over 6. Everything closest to the y-axis was over 3. And then the middles are over 4s. And then we said in the first quadrant, we just do pi. In the second quadrant, our numerator is 1 less than the denominator. Third quadrant, it's 1 more than the denominator. Fourth quadrant is 1 less than double the denominator, or 5, 7, 11. And then we went back and we filled in our coordinate points, which means we went right 1, up 1, left 1, down 1. And then every over 6 got the coordinate point root 3 over 2 and 1/2. Every over 4 got the coordinate point root 2 over 2 and root 2 over 2. And every over 3 got the coordinate point 1/2 and root 3 over 2. If you don't know it yet, write it down. This is one of the most important things, okay? We're going to add on to this today our tangents, and we're going to learn how to use those too. All right. So how is that formed? The entire idea behind a unit circle is a circle with a radius of 1. So x squared plus y squared equals 1 is how your unit circle is created. Your center's at 0, 0, and your radius is out 1 in each of those directions. That's where the general shape came from. Then we started to build these special angles. We went 30 degrees, we went 45 degrees, and we went 60 degrees. And we used the lengths of the sides of 30, 60, 90, 45, 45, 90, and 60, 30, 90 triangles to fill in the sine, the cosine, and the tangent, we fill in the coordinate points, which leads you to the sine, the cosine, and the tangent. So those 6 trig functions, which hopefully at least sine, cosine, and tangent sound familiar. Okay, they are spelled S-I-N-E, but abbreviated as S-I-N. C-O-S-I-N-E, cosine abbreviated as C-O-S, and tangent abbreviated as tan. And then their reciprocal functions are cosecant, secant, and cotangent. Cosecant is abbreviated as CSC, secant, SEC, and cotangent, COT. So hopefully you remember the word SOHCAHTOA, yes? Do we remember SOHCAHTOA? That's if I have a right triangle. So if I have a right triangle, I can use opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so now what happens? So there's like 2 ways to do sine, cosine, tangent. One is using right triangles, and we will spend the next section doing that. That's 4-3. Today we're going to learn how to use sine, cosine, and tangent using our unit circle, okay? Unit circle uses your coordinate points. So the sine is the y, the cosine is the x, and the tangent is the y over the x. And then to get the reciprocal functions, you would just flip them. If I had sine, I would put 1 over it or flip it to get cosecant. If I had cosine, 1 over it or flip it, gives me the secant. And if I have my tangent, I flip it to get the cotangent, or x over y. Okay, so now think of these 3, okay? If I took these 3 coordinate points, now the long way to do this is to take every single one of them and put y over x. So if I wanted to find the tangent of an over 6, I would do 1/2 divided by the square root of 3 over 2, and then I'd have to multiply by the reciprocal. These cancel. I'd get 1 over root 3, and then I'd have to rationalize. So I'd multiply by root 3 over root 3, and I get root 3 over 3. That is the tangent of every over 6. When I do over 4s, I'd get root 2 over 2 over root 2 over 2, which is 1. 1 is the tangent of every over 4. And to get the tangent of an over 3, I would get root 3 over 2 over 1/2. And then I would flip it. And I get root 3. So if you can add these onto your memorization of those 3 coordinate points, you've now eliminated a lot of work. What I don't want you to do is have to do y over x every single time, okay? I want you to memorize that an over 6 has root 3 over 2, 1/2 as its coordinate point, and its tangent is root 3 over 3. I want you to memorize that over 4 is root 2 over 2 and root 2 over 2, and its tangent is 1. And I want you to memorize that an over 3 is 1/2 and root 3 over 2, and the tangent is root 3. The trick for me to remember the tangents is that if it's an over 6, it takes 2 3s. I need a root 3 in the top and I need a 3 in the bottom. If it's an over 3, I only need 1 3, which is just root 3. And then hopefully the 4 is easy because it's the same y as the x, right? Okay. So now if you went back to that unit circle, you could literally add in all of your tangents. So now if I went all the way around, and this is what I would do on the outside, I would add in every over 6 is root 3 over 3, every over 4 is 1, and every over 3 is root 3. And I would do it again, root 3, 1, root 3 over 3, root 3 over 3, 1, root 3, root 3, 1, root 3 over 3. Now let's talk about those signs, positive, negative. In the first quadrant, both the x and y are positive, right? So what's going to be true about my tangent? It's going to be positive. In the second quadrant, what's true about your positive, negative signs? X is negative. Y is positive. What happens when you divide a negative by a positive or a positive by a negative? It's negative. So all of these tangents are negative. In the third quadrant, what's true about your signs? They're both negative, which means my tangent positive, good. And in the fourth quadrant,
the y is negative, the x is positive, which means that the answer is going to be negative.
Perfect. The y is negative, the x is positive, which means I get negative tangents, okay? The other acronym you can use to remember that is all students take calculus, and that refers to which trig functions, only of your initial 3, so we're not talking about the reciprocals, just of the initial 3, are positive in each quadrant. In the first quadrant, all of them are positive. That's what the A stands for. In the second quadrant, sine is positive, which means cosine and tangent are negative. In the third quadrant, there's a T. Tangent is positive, which means sine and cosine are negative. And in the fourth quadrant, C is positive, which means cosine is positive and sine and tangent are negative. All right, so now let's apply it. Example 1 says, use the figure at the right to find the trig functions at T. Notice this time it's actually giving you the coordinate point. It didn't ask you to, it's not giving you the angle and you have to find the coordinate point. It literally gives you the coordinate point. So my x is 1/2 and my y is root 3 over 2. I'm going to find all 6. So I'm going to find sine of t, cosine of t, tangent of t, and then I'm going to find cosecant of t, secant of t, and cotangent of t. Which coordinate point is your sine? X or Y? Y. Remember, like if you think about it, it's X comma Y, and cosecant or cosine, the C comes before the S. So the S is your Y, which means root 3 over 2, which means the X is your cosine 1/2. And let's say we don't know this angle, so I didn't memorize the tangent yet. I would put root 3 over 2 over 1/2. Keep, change, flip it, and I get just root 3. And then to get your cosecant, your secant, and your cotangent, we're going to flip them. We're going to flip them and rationalize. So square root 2 over square root 3 gets rationalized because I multiply the top and bottom by root 3, and I get 2 root 3 over 3. Secant, I flip 1/2. That becomes 2. And cotangent, I flip. That would be root 3 over 1, so it would be 1 over root 3. And I rationalize it. Good. Now, it didn't give you t, right? But think about it. What value would be t? What angle is that? When my sine is root 3 over 2, my cosine is 1/2, and my tangent's root 3. Which tangent is root 3? What's the denominator? Over 3. So that angle is pi over 3. All right, now go a step further. find the coordinate point on the unit circle that corresponds to the real number t. So if you knew your unit circle, like if you fill that out first, which is what I would recommend you do on the test, if you fill out your unit circle first and then it refers to an angle on your unit circle, you simply find that angle on your unit circle, get the point. If not, you might have to apply it, which we're going to talk about in a second. But I also know that if it's an over 3, that my coordinate point is 1/2 and root 3 over 2. So I know that without looking at my unit circle because I know it's an over 3. Now I got to figure out what quadrant it's in if I want to do this out of, again, not looking at a unit circle. And in order to do that, this is a 0, this is a 1/2 pi, this is a 1 pi, this is a 1 and 1/2 pi, and this is a 2 pi. So in which of these 4 corners would 2/3 live? In the second quadrant. And in my second quadrant of all students take calculus, which coordinate point is positive and which coordinate point is negative? The y is positive, the x is negative. So now I should be able, there's the coordinate point, and I didn't need my unit circle to do that. That's the idea, is eventually you want to get there. Obviously, if you had your unit circle in front of you, you would find 2 pi over 3, and you would give its coordinate point as the answer. You with me so far? So obviously we're baby stepping to put the two of these things together, because then it will just say to find the sine, cosine, tangent. It could even ask for secant, cosecant, and cotangent given an angle. So we just said 2 pi over 3 was negative 1/2 and root 3 over 2. What would be the tangent at 2 pi over 3? What's the tangent at every over 3? Good, it'd be root 3, and it's in the second quadrant, so it's negative. Good. So my sine is root 3 over 2. My cosine is negative 1/2, and my tangent is negative root 3. Now go to B. Now I have a negative angle. So I'm going to teach you 2 ways to look at this, okay? One way when you're graphing a negative angle is to just go clockwise. So instead of going counterclockwise, we're going to go clockwise. And I only want to go to 1/3 pi, which is going to happen in the first quadrant I hit moving clockwise, okay? The other way, and I think probably the more common way, is find that angle where it's positive. So this is a positive pi over 3. And then fold your graph like a hamburger top to bottom. And where it overlaps would be where it's negative. So that tells me which quadrant it's in. It's in the 4th quadrant, right? And if all students take calculus, that tells me the cosine is going to be positive. Everything else is going to be negative. And it's an over 3 again, which means my coordinate point is 1/2 negative root 3 over 2, because I move right and down. And my tangent is a negative root 3. So my sine, negative root 3 over 2, cosine, 1/2, and tangent, negative root 3. And then go to C. And I get 6 pi over 3. What's true about 6 pi over 3? It's just 2 pi. So check to make sure it can't be simplified first, because if you can't look at that and say it's an over 3, I know that coordinate point, you have to simplify it first. And if it's 2 pi, where is it on your circle? On the right-hand side, right? What's the coordinate point there? 1, 0. What's my cosine? Or actually, let me go in the right order. What's my sine? 0. What's my cosine? 1. What would be tangent? 0 over 1, which would be 0. So if you add in your tangents on your unit circle, on the right and the left it's 0, and on the top and the bottom it's undefined. Then you don't even have to do the work there. All right, domain and range of sine and cosine. So this says the domain of the sine function and the cosine function is the set of all real numbers. My x values, which end up being the angles here, have no restriction. I could ask you to find the sine or the cosine of negative 472 pi or positive 472 pi. There is no restriction to the angle you can try to find. What is restricted is the range. The range of both sine and cosine are from -1 to 1 inclusive, which means the smallest your sine and cosine can be is -1, and the biggest your cosine can be is +1. If you were to look at a circle, right, the furthest point from the center of your circle is your radius. And in the case of a unit circle, your radius is 1. Sine and cosine are also periodic, which means that the functions behave in a repetitive or cyclic manner, and the period for each is 2 pi. That means if I have a circle and I have an angle here, that is, let's say that's root 2 over 2 and root 2 over 2, that every coterminal angle to that angle is going to have the same value. So I could go around this circle 1 time, I could go around this circle 2 times, I could go around it 3 times. It doesn't matter. If I stop at the same angle, all my sine, cosine, and tangents will always be the same. And this is why we do that, because it'll say something like this. Evaluate the trig function using its period as an aid. So is 13 pi over 6 on your unit circle? No, because the biggest thing is 2 pi, right? 13 over 6 is bigger than 2 pi. So when you get, actually, let me go to B first. We'll do B first because it's a whole number, and then we'll go backwards. Is 5 pi on your unit circle? No, too big, right? So the rule on whole numbers in front of the pi are that even whole numbers live on the right and odd whole numbers live on the left. I don't want you to go around your unit circle 2.5 times. If I could literally tell you to find the cosine of 31 pi, I don't want you to count that many times all the way around. I want you to know 31 pi would be on the left, and on the left my coordinate point is -1, 0. And if I asked you to find the cosine of 32 pi, I don't want you to go around 16 times. I want you to know 32 pi would live on the right-hand side, and the coordinate point there is 1, 0. So if the odds are on the left, then what's the cosine at 5 pi? -1, because the cosine is the x coordinate on the left. You with me? Yes? Okay, so now if it's a mixed number, okay, or if it's an improper fraction like 13 over 6, I'm going to turn that into a mixed number. So I'm going to take 13 over 6 and I'm going to make it mixed. What is that as a mixed number?
1 pi over 6.
2 and 1/2, no, 2 and 1/6 pi, right? So when you do this, and pay attention because this will make life a lot easier moving forward because you're going to get a lot of these thrown at you. The whole number part tells you start on the left or start on the right. Even starts on the left, odd starts on the right. So 2 pi tells you to start here on the right-hand side. Wait for it. And then the fractional part of it tells you if you're going to stop in the first quadrant after the whole number or if you're going to go past it into the second quadrant. So the cutoff is 1/2. Is 1/6 less than 1/2 or bigger than 1/2? It's less than 1/2. So I'm going to start on the right because even says start here. And then I go to the first 1/6 after that because it's less than 1/2. And then it's 6. And a 6 is a root 3 over 2 and 1/2. And it's in the first quadrant, so they're both positive. And the sign would be what? 1/2. The y coordinate. Yeah.
Can't you also just minus 2?
Yeah, the problem will be, I could give you something like that. Do you want to keep subtracting 2 pi? No. So convert it. 41 over 3 is what in mixed number form? 41 divided by 3 would be 1, 3, and 2/3. Yep, 13 and 2/3. Do we all agree on that? Yes. So the 13 tells you where do you start? On the left because it's odd. And then the 2/3, less than 1/2 or bigger than 1/2? Bigger than 1/2. So I go past the halfway mark and I put it in the next quadrant. So I know it's the over 3 That's in the fourth quadrant. I know all students take calculus, right? So I would know the cosine there is positive, and I know it's an over 3, so my coordinate point is 1/2 root 3 over 2. Positive x, negative y. So you can do that with literally anything that's a special angle. So it has to end, either has to be a whole number, be an over 3, an over 4, an over 6, or an over 2. And I could give you any number you wanted. Positive, negative, big, small. And you should be able to find the individual trig function, okay? So that's what it means with as its aid. It means it's not going to be on your unit circle. You got to figure it out. We still good? Yes? Okay. Second to last thing in this section is even and odd functions. So even and odd functions tell you whether or not you change your sign on the function. Cosine and secant are called even functions. I'm going to give you a visual and I'll explain why in a second. And all 4 other ones, sine, cosecant, tangent, and cotangent, are called odd functions. Even functions don't change sign. Odd functions do. And this is why. So if you think about the right-hand side of your graph, let's pick pi over 4 and let's pick negative pi over 4. What's the coordinate point at pi over 4?
Square root of 2 over 2, square root of 2.
Good. And what's the coordinate point at negative pi over 4?
Square root of 2 over 2, negative square root of 2.
Good. So what happened to the sign, positive or negative, on the sign of your function, which is the y? What happened there? It changed sign, right? So a positive was positive, a negative was negative. What happened to the cosine of your function? Stayed the same. So the cosine of a positive angle is not going to change when you get the cosine of the negative angle. Whereas a cosine and a secant, because it's a reciprocal function. Whereas sine and tangent and their reciprocal functions do change, okay? And the way you will see this is something, well, let me skip this, hang on. I'll go. Functions we already talked about, right? So sine and cosecant are a pair. If sine is odd, cosecant is odd. So we change. If cosine and secant go together, those would both be even. So you don't change the sign. And tangent and cotangent would both be odd, so you change the signs. Is something like this. We'll do just the first part, then we'll go back. So it says use the value of the trig function to evaluate the indicated functions, okay? Look at A. It doesn't give you a coordinate point. It doesn't give you a special angle. It literally gives you what the cosine of an angle is. So if the cosine of t is negative 1/3 and it wants the cosine of negative t, the question is, do you change the sign or not? And on cosine, what do you do? Do you change the sign or do you keep it? You keep it, which means this is also negative 1/3. And go to B. Again, I'll go back to the last one after this, but go to B. It's giving you the sign of negative t is 3/5, and it wants the sign of positive t. If you change the sign on the angle for sine, do you change the sign on the function? Yes, so this becomes negative 3/5. So now come back here. How would I find secant of negative t? Secant is the reciprocal of cosine. Good. So I go up, and you could come here and flip it and not change it, or I could come here and literally just flip it. And then I go to B. Cosecant is the reciprocal of what? Sine. So I can go to what sine of t is, and I flip it, and I get negative 5/3. So you have to know if you keep the sign or change the sign, and then obviously if it's the reciprocal, you just flip it.
I don't get A. How is it still negative?
Cosine doesn't change. So whether or not you change the sign on your angle, you keep the sign the same on cosine and secant. They are even functions. So I remember like they're even functions because even if you change the sign, you don't change the sign on the trig function. Does that make sense? Cosine, because it goes top to bottom. Top to bottom, my x doesn't change. The negative on the angle would change, but the negative on the x value does not. when you go top to bottom. Does that make sense? Okay, yeah.
Wait, so if you have a negative angle, but it lands you in a quadrant where like the x is positive,
Yeah.
you need to give the cosine, it would be negative, right?
If the x is, so say that again. If you have cosine of an angle that is negative but still on the right hand side, so we're talking like negative pi over 6, negative pi over 3, negative pi over 4, okay? This would actually, so this is in your fourth quadrant. The coordinate point there is positive root 3 over 2 and negative 1/2, right? So that, the cosine of that would be negative root 3 over 2. No, sorry, positive. It's positive. So the cosine at positive pi over 6 is also positive root 3 over 2. The sign does not change. Is that what you're saying? Yeah, okay. You just won't always have this guy. You'll only have the cosine. So if I told you that the tangent of t was 1/5, what's the tangent of negative t? Negative 1/5. Tangent you change, cosine or sine you change, and then their reciprocal functions you change. Cosine you do not change, and its reciprocal function, which is secant, you do not change.
So tangent and sine change, cosine doesn't.
Correct.
Cosine twice.
Because what?
I thought you said cosine twice.
Cosecant.
Oh, okay.
So
Gotcha.
sine, cosecant, tan, cotangent, change. Because they're odd. And then cosine and secant don't change. And they're even. Last thing we're going to do is with our calculators. So this says use a calculator to evaluate the trig function. Round your answer to 4 decimal places. This is when it starts to get fun to use a calculator because our mode is important, right? So what is true about all of those angle values? Are they radians or degrees? They're all radians. There's not a single degree symbol on this slide, right? If I said find sine of 32 degrees, that is in degrees, and that means my calculator has to be in degrees. So if I do that first, let's start here. Sine of 32 degrees, you literally have to go to mode on your calculator and make sure your calculator is in degrees. It's the third one on the list after like Math Classic or whatever. Go arrow over and make sure you're on degree. So that's in the mode menu. Then for sine of 32, I simply hit sine of 32. I hit enter and I get 0.5299 and so on and so forth. Everybody got that, right? Now the rest of it is in radians. And on your test, you are going to have to switch back and forth. So you have to pay attention. There are times when it's in degrees and there are times when it's in radians. The rest of these examples are in radians. So I'm going to go mode. I'm going to go down to radian, select it. Now secant is not on your calculator, right? There is no button that says secant. But what is secant? 1 over cosine. So we're going to do 1 over cosine 4.5. 1 divided by cosine 4.5. And I get negative 4.7439.
What is the sine, negative, and cosine?
That's if you get given the trig function and you want the angle. We'll get there, just not in this section. Yeah. How about cosecant? Obviously not a button on your calculator, right? So we use 1 over sine of 0.9. 1 divided by sine 0.9. And I get 1.2766. And then I get tan of pi over 2. And you could literally type it in. Tan, use the the pi button, which is above the little caret. Divided by 2. What happens when you do that? Error. Why is that happening? Where's pi over 2? At the top. The coordinate point there would be 0, 1. And I would get my tangent by putting 1 over 0. And 0 is in the bottom, which makes it undefined. So your calculator's trying to tell you that, but that's what that means. And then cotangent would be 1 over tan negative 1.2. and I get 0.38877, so 3.3888 would be the answer.
You don't get a negative?
Oh, negative. I don't know if I said it or not, but negative, yeah. Negative 0.3888. Questions on anything we talked about today? Okay.